Okay guys, we're back. We're going to be finishing up this homework problem. So I started you out on the first one. Hopefully you got to finish. But now we're going to look at what happens instantaneously. So we take the derivative and we've got three variables that we need. We need x, we need z, and we need dz dt. Okay, so now let's go look and see what we have. X is horizontal distance, and so that's going to be the 276 because we're not using feet, we're going to use the 276. So that's going to be 2 times 276. I'm going to change that because that was wrong anyway. And dx dt is what we're looking for. And 2, and then the z. Now the z we don't know. The z at the instant when our x is 276. When our x is 276, our y is 156, but our z we don't know. So at this instant, we've got to do this little Pythagorean theorem here. And we're going to have 276 squared plus 156 squared square root. Now, if you're not used to doing the Pythagorean theorem in this particular fashion, let me know, and I'll see if I can take a few minutes in class one day to explain that to you. It's real simple. Okay, so getting out my calculator, I'm going to do the square root of 276 squared plus 156 squared. Okay, and so I get 317. 317.04. That is going to be z. And then dz dt, that is what we were told at the beginning, that it was -5. That the line is changing at -5 minutes per second. So if we divide both sides by 2, and then divide both sides by 276, that'll give me my dx dt. So, get my calculator to help me out. And when I do this, let's see, I get -5.74. So my horizontal change is -5.74 inches per second. Okay, so if we just think it through, this one is changing at 5 inches per second, and this one is changing at 5.74 inches per second. And I hope that makes sense. But that's what's going on here. So hope that would help you with number 4. Let's move on to number 5. Okay, so number 5, we have a piston, and your numbers can be different, but I've already kind of started this problem. In my problem, it has a radius of 4, a speed of 3 centimeters per second, and we're looking for the rate of change of the volume when the piston is 15 centimeters from the base. Okay, so our height is 15, okay, and it's going down. Okay, our rate of change of volume is going to be decreasing. Our speed is 3. All right, and so volume of a piston is what we're looking for. So our formula for volume of a piston is volume is pi r squared h. Okay, and we're actually looking for the rate of change of the volume. Okay, so we're looking for dv dt. Now this one, I'm going to need the chain rule. I'm going to need the chain rule, not the chain rule, I mean the product rule. I'm going to need the product rule to do the derivative here. Okay, so if you remember, the product rule is the first times the derivative of the second plus the second times the derivative of the first. Now the derivative of the first, pi r squared is 2 pi r and then dr dt. Okay, so using the product rule, the first times the derivative of the second plus the second times the derivative of the first. Okay, And now let's see what we can plug in. Let's see what we know. All right. Do we know our radius? Yes, we know our radius. So let's check on that one. Our radius is 4. So that's going to go there and that's going to go there. Our speed. Now, our speed is the speed of the chamber. The piston is at the top and it's pushing down. Okay. And so that's what this is right here. Right? And that is technically a change in height. Right? So that is our dH dt. That's our dH dt. So that's 3. Okay. Now, we know pi. We got 2. We got pi. We know radius. Our height is 15. And then our radius. Our radius. Well, dr dt is the rate of change of our radius. Well, our radius is not changing, is it? Our radius is constant. So that's 0. So let's look at what we have here. We have pi, r is 4, dH dt is 3, plus 2 pi times 4 times 15 times 0. We don't need that. Oh yeah, and our speed is going down, isn't it? Our dH dt is negative. I forgot that part. Because it's going down. Our speed, our volume is decreasing. Our height is decreasing. Okay. All right, and so that's it. So when I type this in, I get 16 times negative 3 times pi. Let's see if that works on my calculator. And I do that on my calculator, and I get negative 150.80, and that is the rate of my volume changing. And volume, what's the unit for volume? Centimeter cubed per second. Okay, so again, something's not changing, then the rate of change is 0. That should make sense. And so that made that all 0. And so there we go for that one. Okay, the next one, we have a water tank. Now this is the hard one. This is the one I got stuck on in class the other day. So we're going to stop this video and we will start this problem on the next video.